So to start off with, let's have some revision of what our inverse sine, cosine and tangent graphs looks like. Starting with inverse sine graph, so we want to remember firstly what the graph itself, the basic shape looks like. So the basic shape is this, passing through 0, 0 here, going like that. And this is something that I can't help you any more than telling you that you just need to memorize it. The other things that we need to memorize is the domain, whereby the x is between -1 and 1. So you'll see in a lot of your textbooks that it'll be written as the domain is this. But what I want you to think about it as this is the input. That is, the input for your inverse sine graph must always be between 1 and -1. And I'll tell you later why that's important. And now the range is between pi on 2 and -pi on 2. But once again, I want you to consider this as the output rather than the range. Even though in your books and exams, if it asks for the domain, you write this and then you write that. But for the purpose of these more difficult questions, it's best to consider them as input and output. The other thing that we must also remember is that when we have inverse sine of -x, that just becomes negative inverse sine x. So you can essentially just take that negative outside of that. All right, so it's only 4 things you need to remember. That is the basic shape of the curve, which looks like this, the input between 1 and -1, and the output between pi on 2 and -pi on 2. And then finally, this is quite easy, inverse sine of -x just becomes negative inverse sine x. All right, so if you don't know this, I'll just spend a couple of minutes memorizing this, because otherwise the questions we do later on will be quite difficult. All right, let's use this information now and have a look at some of these questions. So starting off with question 1, we have y equals the inverse sine of 2x, and we want to state the domain. So why I want you to consider that as the input is that the input into inverse sine is 2x, and that is what's between 1 and -1. So it's not that x is always between 1 and -1, but rather the input is always between 1 and -1. And then to work out the domain of the input, we just need to divide everything by 2. So we get that the domain is x must be between -half and half. So can you see the difference between the domain there? Whereas that's just working out the input. So now we've worked out the domain for that, graphing it on the x and y axis between -half and half. Let's work out the range. So the range was the output. And so the output here is your inverse sine, that entire thing. So that's between -pi on 2 and pi on 2. That already looks like that. So this is the range. So sketching it on the curve between pi on 2 and -pi on 2. So I've worked out the domain and now the range. Finally, let's sketch the graph. And to do that, what you want to do is once you've drawn the domain and range, draw a box around, or you can just imagine this box. And the curve of sine, the basic curve of that, you just draw within the box. Yeah? So you don't actually need to draw the box, but imagine that box and draw the curve within that. And this is going to be your curve. And now be really careful. We don't want arrows on the end of that, do we? Because we have specified domain and range. So it doesn't keep going. It stops exactly at this point and exactly at that point. Okay? All right. So you can see why now I was very set on you considering the idea of input and output rather than domain and range on the first page with that information. It's because by using the input and output, that's what we use to work out the actual domain and range for these questions. And the other thing to be careful of is to not put arrows on the end of this. All right, great. So that was our nice and basic introduction to this. Let's have a look at something else similar but a little bit more complicated. So starting off with the domain, we always start off with this is the input. So the input is between 1 and -1. And we want to make x by itself. How are we going to do that? Add 1 to everything. So that becomes 0 and 2. So my domain is between 0 and 2. Put that on the graph, between 0 and 2. Great. Now with the range is your output, isn't it? So your output here is this entire value. So we know the range is just going to be between -π/2 and π/2. Now we can just sketch out into the curve, π/2, -π/2. And to graph, what we need to do is imagine that box around, and then finally we just draw our basic sine curve in there. But what we need to be careful of is we know it's going to cross the x-axis in between our two values that the domain is between. So if it's between 0 and 2, we know it's going to cross at 1, and I want you to label that because it makes them more specific. All right, great. So this one, we worked out the domain, the range, plotted that on the curve, and then finally, by imagining the box, we were able to sketch the graph. So that's a basic idea that we want to go through. Domain, range, plot it, imagine box, sketch a graph. Easy, right? All right, let's have a look here. So question 3, domain, we want to consider the input, and that's just x. So the domain is just going to be between 1 and -1. Plot that on the curve. And now the range. Be careful here because the output is not 2 inverse sine x, but the output is actually just this. Yeah, because the question's asking you for 2 times the output. So the output is just inverse sine of the input. So therefore, it's this that's going to always be between -π/2 and π/2. And what we need to do is to make that look like that. So to do that, it means we need to, we just need to multiply everything by 2, right? So that means that the range for this is just going to be between -π and π, okay? So between π and -π. So sketching the graph, I imagine my box, and then I just sketch the sine curve in there, and making sure to end exactly at those points. All right, so the only difference here was our range this time was modified. So when you have a pronumeral in front of your inverse sine, just remember that's not part of the output. It's just going to be the output times 2, times 5, whatever that number is. And what you want to do is make the output look like that, and that's how you work out the range. All right, great. So that was question 3. Let's have a look here at question 4, where we're going to be working with -x. So we have y equals to inverse sine of -x. So the domain, this is our input. So that's going to be between -1 and 1. So multiply everything by -1. We get 1, and this becomes -1. But because we're multiplying everything by a negative, it means the sign flips. So this greater than will become a less than, and this less than will become a greater than. So essentially, that's actually exactly the same as that, isn't it? X greater than -1 but less than 1. So our domain is going to be the same. So draw that there. Now with the range, what we want to do is start off with our basic range. So we know that the basic range for the output is that inverse sine x is going to be between -π/2 and π/2. And now we want to multiply everything by a negative. So in the same way, this remains the same because the signs switch. And we know that inverse sine -x equals to negative inverse sine x. So therefore, this is the same as that. So that's why the range is going to be between π/2 and -π/2. So sketch that in. And now just imagine a box. Sketch the graph. Now what's really important here is because it's going to be a negative, we have to flip the curve. So you know how the curve is usually that way, because it's a negative, we have to flip it. So it goes this way. All right? So important things here is that when we were working out the range, we start off with the original output range, which was that inverse sine x was between negative pi on 2 and pi on 2. And then we change that to equal that. Yeah? So we're changing that by knowing that the property of inverse sine negative x is that it equals to negative inverse sine x. Okay? So I don't want you to put that straight away and make it equal to that domain. Even though it does give you the same answer, it's important that you go through that process so show the examiner you understand what you're doing. All right, and the other important thing is negative x, right? Always draw the curve with a flip. So instead of this, you always draw the opposite of that. Great. All right, let's have a look at question 5 here. So we're working with negatives here again. We have y equals to negative inverse sine x. Okay, yeah, that's really great for those of you who thought, well, that's quite similar to the question before, right? Because this is the same as inverse sine negative x. So we know it's going to be quite similar to the graph before, but let's work through the process anyway. So starting off with the domain, this is our input. So our domain's just going to be between 1 and negative 1. So quite simple. Let's plot that onto our graph. Now with the range, can you tell me what the output is going to be? That's correct. It's just going to be this part there, right? Because it's just the inverse sine of the input. So it's just that between negative pi on 2 and pi on 2. And we want to make it look like that whole thing, and how we're going to do that is by multiplying everything by negative 1. And when I do that, this becomes pi on 2 and that becomes negative pi on 2. But because the signs flip, it essentially becomes the same thing. So the range is still between negative pi on 2 and pi on 2. So I plot that on, and now I can just, if I want to sketch the graph, I need to consider the box around. But remember how I said this is the same as that? So essentially we're working with negative x again, which means that I need to sketch a curve flipped around. So the curve is going to look like that. Yeah? So remember, if we just have negative inverse sine x, or if it's negative x as the input, both of these, I need to draw the curve flipped around. So I want you to remember that for both of these, always flip the curve.